that a very brief introduction about myself, and I will thanks the Government Science College Bilaspur for inviting me to deliver a lecture in a series of lecture for I think UG and PG students, and this lecture will be very useful for a undergraduate and a postgraduate students, and we know that we know what is first of all what is a mass spectrometry and its application. So this slide showing we know already J.J. Thomson. J.J. Thomson, he is from Cambridge University. So he was recorded first time mass spectrum of any molecules. So this is the we can say very starting of a or development of a mass spectrometry. Later on, the Francis W. Eston recorded mass spectrograph, and for this great pioneer work, he got the Nobel Prize in 1922. So we should know what is a mass spectrometry. So here the word mass means we know that weight of molecules, and spectrometry is related to the spectra, and I will tell about what is the difference between a spectroscopy and a mass spectrometry. Sometimes during the examination, students generally write mass spectroscopy, but I think that mass spectroscopy term with mass spectrometry is wrong, because that we know that spectroscopy means that electromagnetic wave interact with the molecule, and we are getting the spectra. So that is about spectroscopy. Means that spectroscopy may be atomic spectroscopy or molecular spectroscopy. So with mass, we have to write spectrometry, because mass spectrometry is not a spectroscopic technique. It is a separation technique. So I think we should aware of the word mass spectrum, mass with a mass spectrometry, and we know what do you mean by mass spectrometry? What is the application of a mass spectrometry? So we know generally if we want to weigh the bulk or body of a ourselves, okay, so we have to use a weighing balance, and during past time we are using this physical balance for weighing several chemical substances. Now that this digital analytical balance taken the work of this physical balance. So with this digital analytical balance, we can measure the weight or mass of molecule up to microgram. Okay, but if you want to weigh the mass of molecules and atoms, then what we will use? Then that time we will use a mass spectrometry, and okay, so what is a mass spectrometry? Mass spectrometry is that described the smallest scale in the world, not because of a mass spectrometer size, but because of the size of its weight or molecules. This means with mass spectrometry, we can determine the molecular mass or atomic mass of a chemical substance up to 10 to the power minus 23 gram. Means we can measure means attomole or femtomole of chemical substance present in any given sample. Then we have to understand what are the different components or part of a mass spectrometer. So that is used to determine the molecular mass of any molecules. So generally use of mass spectrometer, we can determine the mass of any chemical substance present in a water sample or biological sample like blood, urine, or maybe food samples, we can determine what type of the molecules present in a unknown samples, and also we can know means what type of the structure of the unknown molecules present in sample. So here we will this slide showing the different components of a mass spectrometer. And in a PG or UG during the examination, there is some question. Write the different components of a mass spectrometer or different parts of a mass spectrometer that will use for a determination of any compound mixture in a sample. And that this ionization, okay, ionization is one part of a mass spectrometer. Then we have a analyzer and a detection. So generally the function of a this ionizer, okay, ionizer or it means one part of mass spectrometer, there is ionization and disruption of a molecules takes place. And if you want to get mass spectrum of any molecule, so that molecule should be ionized, okay. So that is a important condition of a mass spectrometry. Then analyzer. The analyzer means the molecules will be sorting out based on a mass by charge ratio. So we will see later in detail. Then the third part is detection. So detection we can means what are the molecules that is a detected in a mass spectrometer. And in a mass spectrometry, samples like solid, liquid, or vapor can be introduced in a ionization source, then followed by the analysis and detection of a chemical substance. Then we have to know there are different types of ionization source. EI means electron ionization, CI chemical ionization, FAB fast atomic bombardment. Then we have ESI electro spray ionization, and MALDI matrix assisted laser disruption ionization. So these are the different ways by which we can ionize the molecules in a mass spectrometry. Then as I told, there are different analyzer. Okay, so like sector, Q means quadrupole, QIT, quadrupole ion trap, TOF, time of flight, FTICR, Fourier transform, uh, ion cyclotron resonance. So this means what is the use of this analyzer? So this analyzer will sort out the molecules in a mass spectrometer based on a mass by charge ratio. And use of different analyzer, they have a different resolution, accuracy, or precision during the analysis of a chemical substance in a mass spectrometer. So we will see in a detail means what is the EI, CI, FAB, or different types of a analyzer. So here there is again another question, like maybe simple type of question in a UG or PG. Write the principle of the mass spectrometry. Okay, principle of mass spectrometry. Then we have again defined this principle of mass spectrometry by first we have to introduce the sample into the instrument, and then this instrument, the ionizer part of the instrument, ionize the molecules. Then we have a mass analyzer. These ionized molecules will pass through the analyzer. Then we have a detector. It goes to the detector for a detector, and we will have different types of detector like photomultiplier tube or a micro channel plate. We will see in detail what is a photomultiplier detector or a micro channel detector. Then we have a different ionization method. Okay, so here we have to understand what are the different ionization method, because this ionization method decides the how much that amount of a or how much molecular weight of a chemical substance can be used using a different ionization method. So first one is electron impact. So that is in abbreviated form we can say EI. And this electron ionization is a hard technique. You will see why it is called hard technique for ionization of molecules. And using this EI, we can analyze any chemical substance from 1 to 1000 Dalton or a molecular mass, and a fast atom bombardment. So this is called semi-hard, and we can analyze the any chemical substance up to 6000 Dalton. Then we have the electro spray ionization, and that is a soft ionization. We will see why it is called soft ionization. And using this electro spray ionization, we can analyze peptides, protein up to 200,000 Dalton. And last, we have the matrix assisted laser disruption ionization. And using this technique, we can analyze up to 500 kilodalton of any molecular mass. So these are the different ionization technique using for a different molecular mass of compound. So we will see in detail what is a electron impact ionization. Okay, so in electron impact, so the word telling electron impact. So the electron collide with the molecule and the molecule will ionize. So here we will see how how the electrons produce from what type of a target element. So generally, if we will heat rhenium or tungsten filament electrically, then there is a release of electron from its surface, having energy of 70 electron volt, and that energy of electron is used to ionize the molecules from a sample. So here this is a electron from some target metal, and this that electron will collide, or we can say bombarded. We can use another word, bombarded with the molecule or the compound mixture. Then we will get electron from a electron gun, and another electron from a molecule is released. Then we have a molecular M plus, or we can say the molecules is ionized. So as I told, the condition of mass spectrometry is we have to ionize the molecule to get a mass spectrum. So here we will see what is the principle, how we are getting a mass spectrum of a molecules, and we will also see how the molecules are getting ionized, and we will get a different peaks in the mass spectrum, and that getting the different peaks, how we can decide the compound, okay, unknown compound present in a sample. Suppose we will put, so this is a structure of the propane, and if we will put this molecule propane in a mass spectrometry, then what will happen? As I told, so suppose, so this propane having three CH bond. So here we have CH bond, CH bond, CH bond. So we will take the one CH bond of this propane molecule, and we know this CH. We know that carbon having 6 core electron. One core electron is used for a bonding with a hydrogen, and one bonding electron from a hydrogen. Then I told, when we will heat the molecule with the electron beam. So this is like shooting the any molecule with the electron gun. Then what will happen? One electron from this core electron of a carbon will be evacuated out, and then we will get this molecular ion or a radical. So this is called this is a formation of a molecular ion peak in a mass spectrum, in a mass spectrometry. Then so now we will put this molecule in a mass spectrometry, and here we have ionization source. So from ionization source, electron beam will be produced and hit the molecule, and we will get this molecular ion peak. Then what happens? This molecular ion passes through the magnet and reach to the detector in a mass spectrum. And so here, because we can see this molecular ion peak follows the curvature in a mass spectrometry. So here we can write the radius of this curvature, and using this here is some physics are involved. Means how here we want to calculate what is the radius of this curvature of the molecular ion peak reaching to the detector. And here we can see we are putting this molecule in a magnetic field. So we have a magnetic field, and the molecular ion peak follows the some curvature. Curvature means that will have a centrifugal force, and we know that a magnetic field will have equal to QVB. Q is a charge of a molecule. V is a velocity, and B is a applied magnetic field. M is a the molecular ion peak. Then we have a radiation. Then this formula becomes the velocity from both sides will cut, and we have this equation. And finally, we can determine the radius of this molecular ion peak in the mass spectrometry. And if you will determine the radius, we can determine the mass of any molecules. Okay, so which is a put for an analysis. Then so now when the molecule reaches the detector, we will get this molecular ion peak, molecular ion peak at a 44 m by z or m by q. Then so first we have a understand the sorry. First we have understand the removal of core electron from the molecule. Next, there is possibility of hitting electron beam to this bonding electron. Suppose this bonding electron will remove, then this hydrogen will release from this molecules. And this hydrogen with one electron is a neutral species, so it will not detected into the detector, and we will get the this CH3 CH plus and CH3 in the mass spectrum. So here I can say suppose one hydrogen, so there is another, and that I told, there is a possibility of a release of a this proton from the molecular from this propane molecule, and we will get the fragmentation of a this molecule at a 43 gram per mole. And then we will get the molecular mass peak at a 43 gram per mole. And so here we will get for fragmented peak in the mass spectrometry. Another possibility of fragmentation of this propane through this bond, and this CH3 cation will release from this molecule, and we will get peak at a 15. And another possibility of a possibility for a for CH3 CH, and there is another possibility for a fragmentation of this molecule from a propane, and we will get peak at 28. So these are the peak at 15, 28, 43. these are called fragmented peak of a molecule in a mass spectrometry. So here we must understand also the base peak molecule. So this one 44, the peak at 44 is called molecular ion peak, and 43 is called base peak, because this 43 is a 100% abundance in the mass spectrometry. So that are called base peak. And other peak like 15, 28 are called fragmented peak or data ion peak in the mass spectrometry. These were about the means fragmentation of any molecule in a mass spectrometry, and and for a particular molecule we will have some specific fragmented peak. So that is, we can say, fingerprint of a any molecules, and based on that fingerprint of fragmented ions in the mass spectrometer decide the identity of molecules. As we know that what that electron ionization. So this is a part of electron impact ionization. So as I told, the filament, that is a tungsten filament, when it is electrically heated, it releases electron from a molecule, and these molecules are ionized and pass through the extraction plate, and it goes to the analyzer for a detection. So here I will tell about the fragmentation pattern or electron ionization of molecule in a MS mass spectrometry. So here that simple example of methane. When methane is ionized with the electron, then we have the molecular ion peak. As I told, that core electron from the methane is removed, then we have a molecular ion for a methane. So that is also called a radical cation. And then this will show the molecular ion peak for a methane in a mass spectrometer. Other possibility of getting this so this is the molecular weight is a 16. So we will get for methane peak 16 as a molecular ion peak, and we will get a 15 as a fragmented peak or cation peak in the mass spectrum. So this is about the fragmentation pattern of ethane using the electron ionization technique. So if you want to get the mass spectrum peak for a methanol in a electron ionization, so we will there are a different possibility. So we will get peak 32 as a molecular ion peak, then 31 one is a fragmented peak. So this one is showing the base peak. So what I mean, suppose if you are getting the base peak, what is the significance of base peak in the mass spectrum? This showing the abundance, means more number of these fragmented peaks are formed in the mass in mass spectrometry, or the stability of this fragmented peak is more in a mass spectrometry. Then we have the peak at 15. Like here, there is also possibility of a fragmentation of a CH3 molecule, means cation in the mass spectrum. Then the electron ionization spectrum of a methyl bromide. So we will this is the mass spectrum peak for a methyl bromide. So we can see, means what are the possibility, as we seen the possibility of breaking of a molecule through the bonding between the carbon and some group, or maybe the core electron. Suppose, so this the molecular weight of this compound is a 90. Sorry. here the molecular weight of this methyl bromide is 96 94. So 99 this 96 and 94 is due to the presence of isotope of a bromide. So we will also give the peak for a uh, peak for a isotopes of a bromide at 79 and 89, and there is also fragmentation of bromide from the methyl bromide, and we will get a cation of a methyl group at a 15. So this is a mass spectrum of a methyl bromide. Then so we understand what is the electron ionization technique. What are the advantages of this technique? This will result in complex mass spectra with fragmented ions useful for structural identification. But there is a disadvantage of electron ionization. Here the energy used in a electron impact ionization is a 17 electron volt, and that will cause a more fragmentation of a molecule in the mass spectrum, and sometimes it is very difficult to identify the fragmented peak from the sample. Then disadvantage of a electron ionization is a removed using a chemical ionization. So in chemical ionization, we will not directly hit the molecule with the electron beam. First we will ionize the chemical. So here chemical ionization means first we will ionize the some chemicals, like we will use some reagent gas like a methane, ammonia or a methane. Then this methane or ammonia is a ionized with a electron beam of a 40 electron volt, less energy than electron impact ionization. Then this methane molecule will ionize. This methane ionized molecule again ionize the neutral CH4 molecule. Then we will get a CH5 plus, and this CH5 plus will used this ionized we can say ethane, this ethane molecule will be used ethane, this C2H5 plus or a CH5 plus will use to ionize the neutral molecule from the sample, and this neutral molecule will ionized in the sense that will abstract one proton from a ionized gas, and it will get a protonated molecules, and these protonated or ionized molecules pass through the analyzer and detector. Then we can get the peak of this molecular ion. And then next another one is a fast atom bombardment ionization. This is the another type of ionization technique. Here instead of a electron beam, we will use some neutral particles. So we will like argon, we will use a neutral particles of argon gas or a xenon to ionize the molecules. And before ionization, the chemical compound or chemical substance is mixed with some matrix like glycerol, thioglycerol, or 3-nitrobenzyl alcohol. So these are the different chemical compound which mixed with the unknown chemical substance, and then this fast particle beam argon or xenon is used, is first ionize the matrix, then this matrix will ionize the molecule present in the sample. Then we will get a molecular peak of an chemical substance. So this is a the mass spectrum peak of some dipeptide using this the magic bullet matrix. So this magic bullet matrix is used to ionize the molecule. So that was about that was about a fab ionization technique. Then we have a soft ionization method. Why it is called soft ionization? Because there is a chance of a little fragmentation of a molecule in the mass spectrum, and there are two types of a soft ionization method. First one is a MALDI. MALDI, here we will use some matrix like cyanohydroxy cinnamic acid. So here we will mix this our sample or molecules with some matrix, and the matrix with sample is ionized with a UV laser light of 330 nanometer wavelength. Then we will get the ionized molecule in the mass spectrometer. Another one is electro spray ionization. So here the term electro spray ionization, electric field is used to ionize the molecules. When we will pass that sample molecules in the capillary tube of the electro spray, then the electric field will use to ionize the molecules in the sample. So these are the different pioneers of electrospray ionization and MALDI. And for this development of a MALDI or a ESI got the Nobel Prize. So this is about the electrospray ionization technique. As I told, the electrospray ionization use the electric field where the polar or volatile buffer solution is passed through some capillary tube having a 3 to 4 kilo electron volt is applied along with some nebulization gas like nitrogen, so that we nebulize the sample and we will get a ionized sample into the mass spectrometry. So this is the diagram for a electro spray ionization. Then so this slide showing the ESI peak for analysis of myoglobin in a positive mode. So we know that the molecular weight of this myoglobin. So this is a type of hemoglobin that present in different type of animals, and the molecular weight is 16,915. Then here is the principle of MALDI. So as I told that in MALDI mass we will mix sample with a matrix. Then laser light irradiate on this matrix containing the sample. Then we will have a protonated or ionized molecules. So that will pass through the mass spectrometry to get a mass spectrum. Then this showing the use of different compound as a matrix for analysis of different like if you want to analyze peptide or nucleotides, we have to use a 2,5 dihydroxybenzoic acid, and if you want to analyze liquid or proteins, we have to use this matrix. So here there are different types of matrix that is used in MALDI for analysis of a different compound, and we have to use a different laser light for analysis when we using a different matrix. Then this is the target plate for a preparation of sample in a MALDI you can say. Then so that were about different types of ionization source. Now we will study we will study different type of a mass analyzer for analysis of a chemical substance. The use of a different mass analyzer will decide the resolution or mass measurement accuracy or a sensitivity of a compound. So we have the different types of mass analyzer like a magnetic sector analyzer, and the use of this magnetic sector analyzer will give high resolution of a peaks in the mass spectrum and exact mass. Quadrupole analyzer will give the again high resolution and fast analysis, and the cost of this quadrupole analyzer are very cheap. Then we have a time of flight analyzer, and using this one we will have a high molecular weight analysis up to 200,000 kilodalton, and having high throughput means we can analyze many samples at a time. And then we have a ion trap mass analyzer having showing a good resolution and all in one mass analyzer. Then we have a ion cyclotron resonance analyzer, and this one is a very giving high resolution and a high accuracy of a mass peak in the mass spectrometry. So this showing the comparison of a different quadrupole sector, time of flight, or API ICR. So we can using this different type of analyzer, we can analyze different weight of the molecules. So using this GCMS having a quadrupole, we can analyze up to 2000. Sector analyzer, we can analyze up to 4000 Dalton molecular mass. So this is about the use of a different mass analyzer in a mass spectrometry. So I want to tell about the sector analyzer. So what is a sector analyzer and how it works? Sector analyzer consists of a magnetic and electrostatic focusing device. And the use of this sector analyzer, we can that separate molecules based on their trajectory path. So that followed in a applied electric field for each ion with a different speed. So this is a sector type of an analyzer. When these ionized molecules from the ionization source enter into the mass analyzer, then the molecule which detected at the detector, only those molecules will be detected which follow the trajectory path. Other molecular ion peak or a fragmented peak thrown out from this sector analyzer. Then this is a physics involved in a electrostatic sector mass analyzer, as previously seen that the molecular, the M by Z is a molecular ion peak peak for in any molecules in mass spectrometer is a directly proportional to the curvature of the molecular ion peak followed in the mass spectrometer, that electron and speed of the that applied voltage and the velocity of that molecular ion peak in the mass spectrometer. Then another one is a quadrupole analyzer. So this quadrupole mass analyzer we can see with this diagram. So this is the actual diagram for a quadrupole mass analyzer. And this quadrupole mass analyzer consists of a four metal rods having a different electrode, positive and a negative electrode. And when the ionized ion pass through this quadrupole mass analyzer, here again the ion which reaches the detector, which follows the also again the trajectory path. And also here the important condition is the molecular ion peak of any molecule will matches the applied voltage and the applied frequency, and that molecules will reach to the detector. So this is again block diagram to understand the the traveling of a different ions in a quadrupole mass analyzer. So here we can see only some of the molecular ion reaches to the detector which matches the applied voltage and the applied radio frequency to the molecule, and other molecules thrown out from the quadrupole analyzer. हेलो हेलो
हाँ हो रहा सर,
हो रहा है
ठीक,
हाँ
कंटिन्यू
कैन आई कंटिन्यू मैडम? हेलो
सर, कंटिन्यू सर.
Okay. Different then we have a time of a flight mass analyzer. So this is also very important mass analyzer that is present in a mass spectrometry. So here the separation of any molecules or detection of any molecular ion peak onto the detector depends upon the travel time into the analyzer, and that will also again follow the mathematical formula. So the m by z of any molecular ion peak in a time of flight depend upon the applied voltage and travel time and a length of a tube. So we will see here. This is the flight tube. Flight tube is a part of a time of flight. Here, suppose we can see the some of the three types of different colors. Molecular ion peaks are ionized in ionization source. Then, when it enters in a time of flight tube, it will follow the different paths. So here we can see the light yellow color moving fastly in a flight tube. So okay. So this here we can conclude that the low molecular mass ion travel fastly, followed by the medium one, then the larger. Based on that one, the different molecular mass of any compound, unknown compound, is determined in a time of a flight mass spectrometry. Then another one we have a ion trap. Ion trap is same as a quadrupole analyzer. Here in a quadrupole we have seen 4 rods, but here we will have again three electrode. Okay, so and that 3 electrodes in 3 dimensional. Suppose we can see 3 molecular ion peak from the ionization source enter into the ion trap analyzer. Then this will have a circular path. Okay, circular path, and the ions which will have again applied voltage to the molecule will pass through the detector, and again we can say the molecular ion peak will which will not having the which will not have match with the applied voltage, then again that will be thrown from the ion trap analyzer. So in this way, the molecular ion peak detected in a ion trap mass analyzer. Then we have a Fourier transform ion cyclotron resonance mass analyzer. So this is a very accurate. So the if you want to get the very accurate molecular the mass peak of any molecules in mass spectrometer, then we have to use this Fourier transform ion cyclotron resonance analyzer. But the cost of this instrument is very high. So here again, here the molecular ion peaks which were ionized in this analyzer will reaches to the analyzer, and here that here the ion follows the path of a cyclic path, and this again the cyclic path the ions will only reach to the detector. Then we have a detectors. So there are 2 types of detector. One is a macro channel plates. So these are these macro channel plates are made up of semiconductor material. When the when the molecular ion peak collide with the ionized molecular ion peak will ionized with this conducting material, it will release a electron, and this electron is directly proportional to the amount of a molecular ion peak coming from the sample. Then we have a another detector that can be used in a mass spectrometry is a photomultiplier tube. Here again the that molecular ion peak coming from the sample strike to the dinodes of a photomultiplier tube, and this photomultiplier tube are producing a electron, and this produced electron multiply many times, or we can say there is the amplification of signals into the detector for a analysis of any chemical substance. So this is about the different components of a mass spectrometry. So here we seen what are the different ionization source. Then we have seen what are the different types of mass analyzer and detectors. Then another part is the application. So how we can use this mass spectrometry or analysis of different types of chemical substance present in samples. So how we will know which molecule having a alcohol, or which molecule is a ketonic group, or which compound having a bromide group. So we will see one by one. So fragmentation. So another one is a fragmentation pattern of any molecules. So in the syllabus, one topic is a Mac-Lafferty arrangement. So here in the Mac-Lafferty arrangement, we will see the how the molecules are fragmented. So before the to understand the Mac-Lafferty arrangement, first we will see the simple fragmentation of different molecules. So here we can see the fragmentation of a methyl group, or the molecule having a different primary, secondary, tertiary carbon. And here we can see the fragmentation pattern of this methyl is very difficult. And like tertiary carbon, the molecule which having a tertiary carbon having a will have a easy ionization compared to secondary one. And these molecules having a phenyl group have a more easy fragmentation pattern. So these are the example of different molecules which where the molecules is directly fragmenting at the bond, means bond between like alkyl group or this carbon. So based on this one, we will get a cation. Cation for suppose there is fragmentation between the alkyl group and methyl group. So we will get a cation, and we will get a radical. And this radical these radicals will not detected in the mass spectrometry, because these are the neutral molecules we cannot identify. To detect any molecules in a mass spectrometry, that should be ionized or having a carbon carbocation. So we will see one by one fragmentation of a different class of molecules. So this is a suppose means how we will get the fragmentation pattern of alkane. So if we want to get the, like this is for methane, we will get for a methyl plus. And if you want to get a fragmentation pattern for ethane, so these are the different fragmentation pattern for a different alkanes. And here one important point: the most stable the molecular INP in a mass spectrometry, that is a tertiary, then secondary, and a primary. This means that if we will have a different, we will have a mixture of a compound of a tertiary carbon chain, or secondary carbon chain, or a primary. Then the tertiary, the carbon will have most stable, means that will show the highly abundance in a mass spectrometry, then followed by secondary carbon chain and a primary. This is a mass spectrum for a hexane. So this is a molecular structure of fragment, and there are different ways by which this hexane can be fragmented. So if there is fragmentation of this peak, we will get peak at a 71, and this at 86 we will get a molecular ion peak. And suppose there is a chance of fragmentation here, then we will get the molecular weight of 5743. So this means if we will put this hexane in a mass spectrometry, so we will get this type of a fragmented peaks in the mass spectrometry, and based on that one we can identify the molecule. The unknown molecule is a hexane. So this is another example of propane. Previously we have seen the same type of a the mass spectrum in a electron ionization. So this graph showing the mass spectrum for a bromopropane. So there is a removal of a bromide from a the propane molecule, propyl molecule, and then we have the molecular peak for a propyl group from this compound. Then, as I told, what is a McLafferty arrangement? So here we will define what is a McLafferty arrangement. So sometimes in mass spectrometry during the fragmentation or a dissociation of a organic ion, it is sometimes found that the molecule containing a keto group undergoes beta cleavage with the gain of a gamma hydrogen atom. So here means what is the McLafferty arrangement? So this is a compound which containing a keto group. So there is a fragmentation of these molecules at a beta bond, and the keto group will extract the hydrogen atom from these molecules. So then we will get a, so there will be fragmentation of this molecule. We will get a neutral olefin, and we will get a enol. So this is the example of a McLafferty rearrangement, and this is one example of the compound which undergoes the McLafferty rearrangement, and we can get the spectrum of this molecule based on the cleavage of a beta bond and extraction of a hydrogen atom from a gamma hydrogen. Then this is another example of a mass spectrum of a propanol. So here, like in a IR spectroscopy, how we can determine the functional group in IR based on their bands. Similarly, in a mass spectrometry, how we can decide the presence of any compound. So if we will analyze any alcohol compounds in mass spectrometry, and there is a removal of water means there is a one oxygen and one hydrogen from OH group, and one hydrogen from this CH2 group. So suppose there is a removal of water molecules from any sample, and so based on that one we can tell the identity of the molecule is a alcohol. So here that if we will know the molecular mass of this compound, and the M plus minus 18, so there is a loss of a molecular mass of 18, showing the presence of propane in a given sample. Similarly, for that the compound which containing a amine group, so there is a, we can see suppose maybe the breaking of the breaking of the molecule at this alpha position. So we can say that compound is having a amine group. Then similarly for the fragmentation pattern for ether, suppose the compound which goes the alpha cleavage and giving the oxynium ion. Suppose, so this is the molecular structure of this the ether, and there is a a release of oxygen ion, showing the presence of an ether. Similarly, for loss of a alkyl group, so we know there is a R and R dash alkyl group. So there is a loss of means a breaking of a the molecule at this place or breaking of the molecule at this place. So we can see the fragmentation pattern of in 4-heptanone. So we can say there is a possibility for breaking of this molecule at this R dash group, or there is a breaking of a R group, and also we can say, suppose, so there is a that removal of carbon dioxide. Similarly, if any molecule having a ethanol or a alcohol group, there is a release of water molecules, so that will decide the presence of a alcohol. So suppose the molecules containing this ethers, so there is a release of a carbon monoxide from the sample, will tell us about the presence of an ether in the compound. Then aldehyde. Similarly, the presence of aldehyde in any compound can be identified by the removal of this aldehyde group from the molecule, from any molecular ion peak, or from a molecules, or there is a loss of a 29 that is molecular ion peak from the compound, will tell us about the presence of a aldehyde. So this is the example of a one compound, hydrocinnamin aldehyde. So the molecular mass of this compound is in 134, and we will get a molecular ion peak molecular ion peak at 134, and here there is a release of a CHO from this molecule. So we will have a molecular mass at 105 due to the removal of CHO4. Then another example is a ketone. So again, there is a loss of R group or a R dash group, as we seen in ethers, and there is again formation of a ethylene ion. So suppose if we analyze these two pentanone in a mass spectrometry, so we will see the removal of a ethylene ion from the sample, and we will get a peak that we are seeing in the mass spectrum. Then ester, so that a presence of a ester in any compound can be determined by the loss of a OR dash group or a R group from the molecular ion peak. So this is a mass spectrum for ethyl acetate, and the fragmentation pattern is a removal of a OR group or a R group from a molecule. So these are the rule of 13. So with the rule of 13, we can determine the structure of any compound, and this rule of 13. So suppose we know the molecular mass of any compound, and that molecular mass of compound is a divided by 13. Then we will suppose if the molecular mass of any hydrocarbon is a 106, then that is a divided by 13, that isotopic mass of carbon. Then we will have a 8 after the dividing the 106 by 13. Then we have a one remainder. Then the 8 plus 2, so that is 10, that will give 10. So that means that 8, the number of carbon is determined by calculating the value 8, and 8 plus uh, 2 will give the number of hydrogen. So the molecular formula for that compound is a C8H10. Then we have another 13 rule. For based on that one, we can determine the structure of any compound using this 13 rule. This is another example. The application of a mass spectrometry. We can use this mass spectrometry for a pharmaceutical analysis, like a determination of viability studies, drug metabolism studies, pharmacokinetics, characterization of potential drug degradation product analysis, screening of drug candidates, and identifying drug targets. We can also use this technique for a biomolecule characterization, for analysis of proteins, peptides, oligonucleotides, and we can use this mass spectrometry for a environmental sample analysis, or a pesticide for environmental samples. We can analyze pesticides in a food sample, or a pesticides in a soil, or a water samples. We can use this mass spectrometry for a forensic analysis. So this is a image of ESIMS, electrospray ionization mass spectrometry. So this is a principle showing the principle for a ESIMS, and we can use this LCMS for a identify drug of abuse in a oral fluids for a forensic toxicology application. We can use this ESIMS for determination of different illegal drugs, banned drugs. Then we have, this is a image of GCMS, and the GCMS, we know that the part of GC will separate the molecules, and the mass spectrometer will separate the molecules, and which can be detected in a mass spectrometry. And GCMS can be used in food adulteration, analysis of acrylamide in a food by GCMS. We can also determine the food colorants, like a chrysodine in fish samples. We can also analyze the phthalates present in some toys. So we can also use this mass spectrometry for determination of a volatile organic compounds, which are a biomarker of a cancer. Then we can determine different types of pesticides that present in fruit samples, or vegetables. And this is a one research work that has been done by our group for determination of a caffeine in a beverages and food sample using the GCMS, where the different amount of caffeine is determined in a different type of Coca-Cola, Pepsi, or Columbia coffee or tea drinks samples. Thank you. Hello.
हाँ सर, यस सर. डॉक्टर कमलेश श्रीवास सर ने आज मास स्पेक्ट्रोमेट्री और उसके एप्लीकेशंस पे बहुत ही अच्छा व्याख्यान दिया. हमारे छात्रों को इससे बहुत अधिक लाभ पहुंचेगा. इसके लिए मैं उनकी बहुत बहुत आभारी हूँ. बहुत बहुत धन्यवाद सर.
थैंक यू मैडम.
थैंक यू सर. जी जी.
Can I close, madam? Can I close?
यस सर.
Thank you.